Next, we turn to factoring expressions known as trinomials. Tri, of course, stands for having three terms. So our outcome is to be able to identify this ax squared plus bx plus c as a trinomial and be able to express that as a product of two factors. In this case, we'll keep a, the coefficient of x squared, to be 1. In the next section, we'll throw other numbers in there. Okay, so when I have a trinomial like this one here, I need to be able to identify that and recognize that I can express that as the product of two things. So something times, there's multiplication in there, something times something is equal to this. It seemed a little bit awkward to do that, but that's what we're doing. We want to take a trinomial expression like this one and express it as the product of two factors. This will help us down the road when we're looking for x-intercepts or when we're looking for zeros. We're solving quadratic equations. This process of factoring is a real handy tool to help us simplify things when we um, are solving or when we're graphing something. Okay, so just as if I take the number 15 and express it as a product of two of its factors, I can do the same thing if I have a trinomial. I can express it as the product of two factors. And we've just done that in the last section, or the one before that, where we took two binomials and multiplied them together to get this. Let's just review that. Remember, to do this, I need to multiply the first together. So x squared, multiply the outer ones together, that would be plus 2x. Multiply the inner ones together, that'd be plus 3x. And multiply the last ones together, that'd be plus 6. Simplifying that, I'll get x squared plus 5x plus 6, just as I had over there. So before we were multiplying to come up with a trinomial. Now what we want to do is take a trinomial and express it as a product of two factors. Now, when you do this, probably the easiest way is to use some kind of a table form like this. Because as we do it, there's a method that you can look to. And what I do when I look at any trinomial, I'm always looking at this last number and I'm looking at the middle number. And what I want is I want to get two numbers that multiply together to give me 6 and add together to give me a 5. So what I do is I go over here and I put the two numbers in. So 6, I could say 6 times 1. When I go 6 times 1, it gives me 6, so that's good. But when I go 6 plus 1, that gives me 7. That's not good. So I'm looking for two numbers that multiply to 6 and add to 5. Okay, so 6 and 1 didn't work. Let's try, of course, 2 times 3. So 2 times 3, maybe I'll put a comma in between these. 2 times 3 is 6. 2 plus 3 is 5. 6, 5, those are my two numbers. So now all I have to do is re-express this, and I put an x in the first slot of each bracket, and then I simply put these two numbers beside them. So one is a plus 2, the other one is a plus 3, and I'm done. It's always good to check, so do your FOIL again to make sure you come up with this first answer. But we've just done this one twice on the last page, so I think we're okay. Let's try this one. Notice this one introduces negative numbers. Let me scroll down a bit. Okay, so I'm looking for, I want to get this, so I have two brackets or two factors, an x in the first slot. Now I'm looking for two numbers to put here. And the characteristics of those two numbers is that they have to multiply to get a negative 27, and they have to add to give me a positive 6. Notice that the signs are important. Okay, so 27. 9 and 3, but it has to be negative 27. So why don't we try negative 9 and a positive 3? Or we could try a positive 9 and a negative 3. You're probably already picking which one it is. Okay, to multiply, minus 9 times 3 is minus 27. Yeah, I'm good there. But when I add these together, I get a minus 6. I'm supposed to get a plus 6. So this one doesn't work. Here, if I multiply those, I get a minus 27. When I add those, I get a positive 6, which is what I have here. Therefore, these are my two numbers that I'll use. So it's a positive 9, I put a plus 9 there, and a minus 3, I put a minus 3 there. Again, I could multiply these out and check to make sure that both these two factors are indeed factors of this. I might as well do that with this one. It's a good practice to do all the time. X times x is x squared. X times minus 3 is a minus 3x. 9 times x is a plus 9x. And 9 times minus 3 is a minus 27. So I'll get x squared minus 3 plus 9 is a plus 6x and a minus 27. Sure enough, I came up with that same thing. So here are my two factors of this trinomial. Good. Okay, here's some other ones. Here we throw p's in. Oh, this should be a p too. But p's same thing as x's or q's or whatever letter you want to use. Okay, so here I'm wanting to get factors. So I know I have a p in the front there, a p in the front there. Two numbers that multiply to plus 20 and add to a minus 9. Okay, so 2 times 10, that would work. That would give me 20. But when I add those, that gives me 12. Yeah, that's way out. It has to be a negative. How about a minus 2 and a minus 10? Those will multiply to a positive 20. Oh, but that gives me a minus 12. How about 4 and 5? 4 times 5 is a positive 20. 4 plus 5 is a positive 9. I got to get a minus 9. So minus 4 and a minus 5. Multiply those as a positive 20. When I add those together, it's a minus 9. Yeah, that's the right one. Notice that I actually went through 3 or 4 of them before I got to the right one, just to show you the process that you go through. But you certainly don't have to go through all of them. Sorry, so you don't have to go through all of them. So here my answer is minus 4 and minus 5. And again, you could multiply, and it's a good idea to multiply those and check. Here's another one. I'm looking for two numbers that multiply to a negative 15 and add to a negative 2. Well, 15, maybe minus 5. I have to get negative 15, so minus 5 and a positive 3. That times that's minus 15. And when I add those together, I get a minus 2. Hey, bang on right away. So this one will be x minus 5, x plus 3. Again, good idea to multiply those out. I'd take some time, maybe pause and check some of those out and see how you do, and then continue on. Okay, here's some other questions where they say factor these polynomials. When I look at the polynomial, there's three terms like there was before, but the first one's an x cubed. That sort of messes me up because it should be an x squared. But when I look at each term, I notice that each term has an x in it. So what I could do right off the bat is I could factor out an x and divide an x into each one of those terms. And then once I've factored that out, now here I've got a normal trinomial. So I could factor it. So again, I'm looking for two numbers that multiply to 54, 9 and 6, and add to a negative 3. I'm thinking x minus 9, x plus 6. That's x squared, be plus 6x minus 9x, that'd be minus 3x. Minus 9 times 6, 54. So there I have it. I've got now three factors of this initial expression. I could do the same thing with this one. One final one, and again, take some time to do some questions if you would like. One final question that looks just a little bit funny is when I have something like this, where I have x to the fourth, x squared, and 14. It sort of looks like this, right? It sort of looks like this one, x squared minus 9x plus 14, except this one has a fourth there instead of a squared. What I could do, and the book shows you a number of different ways to solve this, what I could do is re-express this and say, do a little trick that they use in the book that they say, well, something like they go x squared is equal to u. And so at the first here, I actually have x to the fourth, or x squared times x squared. And then I have minus 9x squared plus 14. And this little trick says everywhere I see an x squared, replace it with a u. So here's a u and there's a u, so that'll be u squared minus 9. Here's an x squared, so that'll be a u plus 14. Hopefully you're catching that. That's a little bit tricky to do that. But now I've got a regular polynomial. Two things that multiply to 14, add to a minus 9. And I could do them just like this. So it would be a u and a u. Two things that multiply 14, 7 and 2. Oh, but it has to be 9. So how about minus 7 and minus 2? Again, I could multiply that out and check to make sure it was correct. So once I've factored this, at this point here, I'm saying let u equals x squared, just so I can deal with a normal trinomial. But once I've factored out this normal trinomial, I have to remember that u is actually x squared. So back here, instead of the u, I'm going to put in an x squared. And over here again, I'll put in an x squared. So those are some that are a little bit trickier. This next one is sort of backwards. The x squared is at the end. And so you could try and sort of go backwards to what we've been looking at before, where the terms are backwards. Or I could re-express this and put it in the right order. Minus x squared plus 6x plus 16. One of the problems I have here, though, is that this first number has a minus in the front. But I could factor a minus 1 out, leaving me with a positive x squared minus 6x minus 16. And then I can have a minus 1. And again, here's just a normal trinomial, so I could multiply it and go x, x, two numbers that multiply to a minus 16 and add to minus 6. I don't know, a minus 4 and 4. When I multiply those as minus 16, when I add, well, it gives me 0. Yeah, that one doesn't work. How about a minus 8 and a 2? Minus 8 times 2 is a minus 16. Minus 8 plus 2 is a minus 6. Yeah, that's the one. That's the one. So I need to put a minus 8 here and a positive 2 there. Now there are my three factors of this original polynomial. If I were to multiply everything together, I would come up with that. This section where we factor trinomials is actually a real critical section to a lot of the things that you'll do in the future. And so if there's any section that you want to do twice or three times, or to work hard on and understand, this would be the one. Replay the video if you want, and how I've factored different parts of the trinomials, and do lots and lots of practice. Again, holler if you have questions.